Okay, back again. Here we are with what we've done so far. We've made this nice 3D wireframe. And next up, as I mentioned before, we're going to be using Boundary Surface to connect this series of curves together to create a surface that we can then mirror over and create a solid from. So let's get right into it. Direction 1. Now, when you open Boundary Surface, this is what you get. You get direction 1 and direction 2. Direction 1 would be 1, 2, 3, 4. Direction 1 is the horizontal. Direction 1. There you go. Direction 2 is going to be from the top down. So the top surface, or the top curve, the center curve, and then the bottom curve. So let's just fill in those blanks. Direction 1. 1, 2, 3, and 4. Now I have a lot of evaluation tools on my boundary surface tool that are activated, and I can turn those off. One is I have the zebra stripes, which we can turn off right over here. If I go down here, zebra stripes, turn that off. And then I have also curvature combs too, which is a very advanced tool that you can use to define the continuity and degree of your curvature on surface. But anyway, let's get rid of that for now. So turn that off, and everything looks a lot easier to understand. So we've used our our 4 guide curves here to define direction 1. Now let's do direction 2. 1 and 2 and 3. There we go. And we'll just scroll around here and take a look at our surface, and that looks fantastic. Very good surface to start. Okay, now we also get all of these kind of confusing things, these little none boxes that are sticking off of our surface here. And if you just roll over the part that has a little colored box next to it, you can grab them and move them around. I like to kind of organize them a little bit to kind of see which ones are doing which. And so let's do that to start. These are telling us the continuity relationships between the different parts of this surface. Every surface has a different part. So for instance, if I just zoom in right here, this back edge right here, this is a flat edge, and it's going to get mirrored across. So what we want to do is we want to go to this thing here and go to normal to profile. Now when we hit normal to profile, it's going to mean that it's going to take this surface and it's going to wrap it in such a way that when it hits this edge here, it's going to make it normal to, which is another way of saying tangent or correct. So normal to the profile is what we want for any surface that hits the edge of what will soon be a mirror. So let me just take another little spin around my model. There we go, and I start to notice that this little adjuster here needs to get definition. So there we go. That touches an edge, so I'm going to make it normal to profile. And then looking at all the other ones, they're just talking about these center points here, so I don't need to touch any of those. So it's just the ones that touch the edge. So make those normal to profile and then hit OK. And voila. We get this fantastic organic form made in Solidworks. So there we go. Okay. So now I'm just going to keep going with this thing. First thing I'm going to do now that I actually have an organic form built from a custom-made wireframe is I'm going to go here to evaluate. Evaluate will help us understand the surface better. Surfacing in 3D CAD is all about understanding, the continuity and the tangency of your surface, trying to understand the curvature of your surfaces that you build, and trying to just make sure that there is nice, clean geometry creating all of your surfaces. Zebra stripes are one tool that a lot of 3D CAD programs use to define a shape. This is something that's created in the automotive industry. Each one of these white lines is a considered like a light reflection, and correct surface geometry will have absolutely perfect tangency between surface breaks, and how light falls over a surface is really the determining factor of whether that surface is successful or not. So in car design and automotive design, they use light stripe rooms where they have full rooms filled with these fluorescent lights that shine beams of light over a surface, and depending on how that light shines off of the surface determines sort of the attractiveness of the car, and therefore determines the saleability of the car and how successful the car can be. So product designers use the same technique. How light reacts on the surface of your product, whatever it is, whether it's even just a toothbrush sitting on your counter, or it's a toilet brush sitting, in your bathroom. The way that thing catches your eye based on light reflections, can determine how much you like that and how much you want to buy it or how much you want to buy another one of it. So, anyway. Looking at this zebra striped, looking at these zebra stripes, I think we're pretty good right here. All the zebra stripes are nice and straight, and there's really nothing to it. So this is a fantastic example of a great set of stripes. So there we go. We can turn that off, and we can mirror this guy over. Let's do that. So mirror face, and let's see, right plane. That's probably the plane we want to mirror across. I think so. Go down to bodies to mirror, select the whole body. We're going to go here to knit surfaces, and we're also going to go to merge solids just because. There we go. We've got a nice mirror across of our surface. Let's take a look at that. Let's turn zebra stripes back on again. And what a treat. We seem to be really right on with this model so far. The thing to look for is, you can see the knit line between the two surfaces, and you can see these light bands and these shadow bands that pass across that knit surface. The fact that they travel smoothly across that surface really means that there's a very clear tangency between those two forms, those two surfaces, and that's exactly what we're looking for. Under here, though, we have a bit of an issue. Let's take a look at that. You can see here, if we zoom in on just the tip, we've got a little bit of a strangeness to this edge here. You can see this sort of ugliness happening right here, and I'm not quite sure on why that's happening. Overall, we do have a pretty clean transition of light and shadow traveling across the two surfaces, except right down here when we get to this point, there's a little bit of a hiccup. Yeah, you can see when you turn that line, or when you turn that model around there, just this point right here seems to be an issue, and we're going to have to dig into that. Everything else seems a little okay. It just seems that maybe the curvature here is just a little bit extreme. Let's take a look at the back end too. If we zoom in on the back end, we see total cleanliness, and the back end couldn't be better. That is gold right there. Let's take a look here at some of the curves that we use to create this boundary surface and see if we can't make some adjustments. Maybe to this top curve, edit sketch. What could it be? Let's take a look at the boundary surface. Edit the boundary surface. And we notice that we have one of these little, excuse me. Let's edit that boundary surface again to bring up its features. What did I just do? I had this is what I was talking about to you guys about moving around your model when you're doing surface modeling, trying to understand things from all angles. Let's just do that. There is a feature inside of the boundary surface that I haven't yet adjusted that I think might help us in this scenario. First of all, I see that normal to profile needs to get adjusted here. There's that. And then also this thing here, tangent influence. Tangent influence is hard to describe in detail to a beginner class, but all I can say is that right now it's at 0 and we want it to be at 100. So once we hit that to 100, we can exit out of this and then take a look at our tip again. And I think we're happy to see that, F to get back to where we started. There we go. The hiccup in our zebra stripes is a lot less than it was before. There we go. Look at that. It's almost perfect. This is really a surface to be proud of as far as SolidWorks is concerned. So we can be very happy with that. And we'll look at the back end, and we have really clean surfacing on there too. Okay, so quite a long drawn out silence on that there, but you can kind of understand that it's important. Let's turn off our zebra stripes and let's just go to maybe real view graphics here. Take a look at our surface with some actual reflections on it, and then now you can start to see how good surfacing really does affect how light moves over your object. And what we want is those reflections that fly from one surface to the other. We don't want any hiccup in those. See how that when that big band, this big band here, that big band of light moves from one to the other, there's no hiccup whatsoever. It stays clean as a whistle. So there we go. Okay. All right, I'll switch out of that. That's just eating up our CPU. So, all right, now we're good to go. But the last thing to finish up is just the fact that this is just a surface right now. You can see it's nice and hollow in there, and we want it to actually be a solid. Okay, let's turn this off, and let me show you just about this last thing, which is thicken. It's under features. Excuse me, no, it's not. It's under surfaces. We go to thicken. We're going to just select all of the surfaces we've created, and we're going to go to create solid form from enclosed volume. If you don't hit that button, you will not have success, so make sure to hit that puppy. Hit the green checkbox, go to your section view, take a look at it, and there you go. There you go. You can switch the parameters of your section view here if you want. You might hit something like that. Don't forget you can move the plane of your section view to show any part of it. Let me just move it to what I want to show. There we go. Showing us that our form is actually all solid there using the thicken command. So, all right, there we go. That is that as far as using boundary surface and also creating a solid form from surfaces, and also troubleshooting a inconsistent zebra stripe or evaluation technique. So again, another lengthy video, but hopefully you've got it, and I wish you the best of luck. Thanks for watching, and I'll see you in the next one where we'll cut this apart and make some individual parts from it and put them together in an assembly.